Welcome. Let's go ahead and talk about some exponents and then exponents in divisions or exponents that are set up as fractions. This ultimately becomes a skill that most everybody masters to a point where you can get through the problems pretty quickly. But this may be a video worth looking at a couple of times because it takes a little while to catch on to some of these for many of our students, even our strong students. So here we go. All right, so when I have matched factors, such as in number 1 here, we've got factor of 5 in the top, factor of 5 in the bottom. I don't do what I'm about to do every time, as you're going to see, but I could always write this out as 5 times 5 times, I got a little lag here. Let's see, 5 times 5 times 5 times 5. Those 6. And put all of that over 5 times 5. Now, if we have matched factors like this, a bunch of 5s in the top, a couple of 5s in the bottom, and what is a factor? It's a number that's being multiplied by everything that's grouped with it. No addition, no subtraction. Then you can just cancel factors. For instance, I can cancel a top 5 with a bottom 5 and another top 5 with a bottom 5. And in this case, I'm left with 5 to the 4th in the numerator. But we don't really have to do that. Here's how I've always handled this. Once I get this situation, I just say, where do we have more 5s? In this case, in the top. How many more 5s do we have in the top? 4. There's our answer. 4 5s, or 5 to the 4th, in the numerator. The denominator's canceled. Of course, we would still write that as 5 to the 4th. So moving forward on to number 2, I have factors of 4, 8 factors of 4 in the denominator, 6 factors of 4 in the numerator, and I would just ask, where do we have more 4s? Well, we have more 4s in the bottom. More by how many? Well, 8 is 2 more than 6. 4 to the 2nd. So 6 4s from the bottom went up, canceled 6 4s from the top, and left the sneaky hidden 1 that I refer to quite a bit. So we end up with either 1 over 4 to the 2nd or maybe 1/16. Depends on what we're looking for at that time, but probably we'll move to a place where we're just calling that 1/16. Likewise, back on number 1 here, 5 to the 4th, common mistake 20. It is most definitely not 20. It is 5 times 5, 25 times 5, 125 times 5, 625. You know, at some point when the numbers get bigger, we just say maybe we'd rather just stick with that for now. Okay, so oddly, looks like number 3 is virtually the same problem as number 2, but again, I have matched factors of 3. Where do I have more 3s? In the denominator. More by how many? I had 8 versus 6. 6 of these from down here. Canceled all 6 from up there. There were 2 left. Sneaky hidden 1. 1 on 3 to the 2nd. And that would probably be one that we would be tempted to square the 3. 1 on 9. Okay? So that's the basics, and now we're going to move on to some things that start getting a little bit more complicated. But as things get more complicated, I don't look at the big picture. I just look, hey, I've got a plain old 8 on a plain old 2. And plain old 8 on 2 reduces by 2 to 4 on 1. So number-wise, I get a 4 on the top, and I might not have to write the 1 on the bottom, but I'm going to. So I'm done with the numbers, and now I just ask, what's left? I've got V's in the top. I've got V's in the bottom. Where do I have more V's? In the bottom. How many more do I have in the bottom? 5. So I would simplify that as just 4 on, of course, 1 times V to the 5th is plain old V to the 5th. And that is it. And all they can do is just add things to it, but all the decisions we're going to make pretty similar, although we'll be talking about some negative exponents shortly. Okay, so very similar to problem number 4, I'm going to start just comparing my numbers. I've got a 2 on a 6. That reduces to a 1 on a 3. And I've got 4 x's up top, 4 x's in the bottom. Where do I have more x's? I don't. These 4 x's cancel those 4 x's. So at that point, I am done. All I'm left with is just a 1 on 3. Number 6. I've got some numbers in the bottom. You may want to put a 1 in front of that x. That's our sneaky hidden 1. And I say, can 1 on 8 reduce? No, 1 on 8 can't reduce. So I end up with sneaky hidden 1 on 8. That's what the numbers do for us. How about x's? Where do we have more x's? Once again, in the denominator we have more. More by how many? 5 outweighs 3 by 2. And we are done. Nothing to it. Number 7. I don't care about 3b to the 7th and 6b to the 6th, or 3b to the 6th and 6b to the 7th right now. I just care about the numbers. 6 on 3. 6 on 3 reduces by 3 to 2 on, I'm going to put the 1 down here. Then I go to the b's. Where do I have more b's? In the numerator. How many more b's do I have in the numerator? 1. So that should most definitely be cleaned up, because dividing by 1 doesn't matter, and raising something to the first power stays the same. B to the first is just b, so solution, plain old 2b. And I don't think it's too much of a stretch to think that we can probably go straight from here to here, if not yet, soon. Okay, well, dramatic shift in number 8, and what our eyes are initially drawn to is probably this negative 8. But I'm going to handle my plain old numbers first. 1 on 4. 1 on 4 does not reduce. And now, if I have negative exponents, I always refer to those as just like elevator tickets. That negative is a ticket to ride the elevator. If you're in the top, you're going to the bottom. If you're in the bottom, you're going to the top. But you're paying the negative to get there. So in the bottom, in the denominator, my x to the 4th stay. But my x to the negative 8ths in the top pay the negative and go to the bottom. So I end up with x to the 8th in our denominator. So am I done? Nope, because I've got a bunch of x's in the denominator to talk about. I end up with plain old 1 in the numerator, plain old 4 in the denominator, and now the question might be, do I have 12 x's in the denominator or 32? Well, I've got 4 x's and 8 x's. If I wrote them all out, I'd have 1, 2, 3, 4 x's. Ooh, I got some lag time here. And then I'd have 8 more of those. All of those being x's, that's certainly not 32. That is x to the 12th. And that's it. So we'll talk more about these elevator rides, these negative exponents, and take a look at those as we move forward. Again, I do not get caught up looking at the big mess. I look at little byte by little byte. 8 on 2. 8 on 2 reduces to 4 on 1. Might not have to write the 1, but I'm going to do that from now. The m to the negative 5, that is an elevator ride to the bottom. The m7, m to the 7th stays, but the m to the negative 5 goes to the bottom and pays its negative for riding the elevator. So I end up with just a 4 up top. I don't need this 1 times. If I leave that as 1 times m to the 12th, it's sort of like saying what's 3 plus 6, and you tell me it's 1 times 9. That 1 doesn't have to be there. So how many m's do we have? 7 and 5. M 12. M to the 12th. 4 on m to the 12th. Okay. All right, one of the things, if you've seen my videos on exponents or been in my class, hopefully you've heard me say a lot of times, is exponents are lazy. This 7 is only covering the n. So there are not 7 2's in there. There's just a single 2 or 2 to the first and to the 7th. But the 4 has been instructed, yep, you can't be too lazy. You got to cover them both. So in the numerator, I've got 2 to the first, but I have 4 groups of 1, 2. 4 groups of 1 is 1 and 1 and 1 and 1, 4. So I've got 2 to the fourth. 4 groups of 7 ends. 4 groups of 7 would be 7 and 7 and 7 and 7. That is multiplication. In the denominator, 8 groups. Those are grouping symbols. Parentheses are called grouping symbols. 8 groups of 5 ends. 8 groups of 5 would be 40. So I might want to just leave 2 to the fourth, 2 to the fourth, but that's such a small number, I'll go ahead and handle that. 2 times 2 times 2 times 2. That's 2, 4, 8, 16. And now I'm going to talk about my ends, and I definitely have more ends in the denominator than the numerator. And of course you could use calculator here, but I'm certain most are going to just subtract that one in our head. How many more ends do I have in the denominator? 40 minus 28, 12. And they stay in the denominator. Okay? Alrighty. Number 11. In the numerator, I've got 3 groups of 4 2's. That is 2 to the 12th. In the denominator, I have how many 2's? 1 of them. So I have more 2's in the numerator by 11. 2 to the 11th. And we may leave that like that. You may be asked to work it out. If so, you probably go calculator. 1,000, that's 2,048, believe it or not. Those get big in a hurry. But 2 to the 11th may be acceptable depending on what the expectations are. Okay, I'm glad we've got number 12 in here looking like it is. I want to make a quick point here. These negatives are just plain old negative numbers. Those are not elevator rides. Here's an elevator ride right here. That's a negative exponent. So before I even worry about the 3 and the 8, I'm going to count my regular negatives. I've got 1, 2. If I've got a negative two negatives in a division problem, my final answer is positive, and I'm done with those guys. They just cancel each other out. Okay? Then the numbers 3/8 does not reduce. And then I look at x's, but I have my elevator ride here. So x8 stays in the bottom, but x negative 7 goes to the bottom, pays as negative on the way there, and we get 15 x's in the bottom. 3, I'll center that a little better on 8. X to the 8 plus 7. 15th power. Ran out of room there a little bit. Okay. Alrighty. How many negatives in number 13? There's just one negative. And it's a plain old negative. It's not a negative exponent. So a 1 negative in a division problem, my answer is going to be negative. The 3's reduce. I could even put 1 and 1 here. And then x's, I don't have any elevator rides. I've got 1x in the bottom, 3 in the top. I've got 2 more x's in the top than I have in the bottom. But we know that the 1's don't have to be written. This is just negative x squared. 1 divided by 1 is 1. Okay, 14. How many plain old negatives are there? I see this negative up here, but that's a negative exponent. Here's the only plain old negative in front of that 3. So I have a positive on top divided by a negative on the bottom. Positive divided by a negative is negative. Numbers. 4/3, does that reduce? Nope. Ends. These 8 ends are staying, but these 8 ends are going. Dropping off the negative on the way down, leaving us with a negative. 4 on 3. How many ends? 8 ends, and 8 more ends. 16 ends. We get intimidated when we see a bigger mess. I just take, it's like 5 easy problems. I don't look at it as one hard problem. It's just 5 easy little things I might have to do, or 6 easy little things. Number 15, before I worry about 3's and A's, I've got a positive divided by a negative. Positive divided by negative is always a negative. Now I move on to the 3's. I've got a 3 divided by 3, that's 1. I'll put the 1's here. That reduces to 1 on 1. These 7A's stay up top. These negative 8A's elevator ride up to the top. Pay the negative on the way. A to the positive 8. So we end up with negative. I'll get rid of this 1. Don't need a 1 to divide by. How many A's do we have? 7 and 8. 15. And 16, compared to what we've been doing, looks pretty simple. But here is the biggest common mistake working with exponents. I'll get somebody say this. Well, 8 times 8, 64. 6 and 3, 9. Do you see what's wrong there? I always say this. If I was to write this all out, I'd have an 8 and an 8 and an 8. All this is multiplied, an 8 and an 8 and an 8. There's 6 of them. And then I would have 3 more 8s. 8 and an 8 and an 8. Tell me where we have 9 64s. We don't have 9 64s there. Multiplying these things, we have 9 8s. We have a bunch of 8s. There are no 64s in here. Okay, just a few more here. Just all review. 2 groups of 3 2's. 2 groups of 3. 2 grouping symbols of 3 is 2 times, I multiply the exponent 2 to the 6th. Or if you are going to work that out, go to calculator if you need to, that is 64. Number 18. Big mess, but this is easy. 8 times 2 times 3. Plain old numbers times plain old numbers. That is 48. 8, I could do it this way. 8 times 6, 48. And the common mistake I would see here is people would say, well, there's 8 x's, 4 and 4. But there's another one here. 9 x's, 48x to the 9th. So I like talking about the common mistakes. Here's another common mistake, number 19. I'll see this. Hopefully you see what's wrong with this. 4p to the 12th. Can you catch it? This 2 is only in charge of the p. Exponents are lazy. But this 6 is in charge of the p's and this 4. 6 groups of 1, 4. That is 4 to the 1 times 6, 6th. 6 groups of 2 p's, that is p to the 12th. And that number gets big in a hurry. Let's see, I believe that is 4,096. You can check that on a calculator, but I'm fairly confident that's accurate. Okay. All right, number 20. I call this what's behind door number 1. It's an old Monty Hall type question, which means almost nothing to anybody nowadays, unless you're my age. But it's based on Price is Right. So I would say, well, what's behind door number 1 here? Whatever's behind door number 1 is being raised to the 0th. Anything raised to the 0th equals 1. It doesn't matter what it is. -7 raised to the 0th is 1. So I don't care what's going on in here. If the whole thing, 3x squared, is raised to the 0th, our solution is 1. That's our favorite types of problems. And we'll wrap up with 2 more. Here we've got some negative exponents again. So forget about the bigness of this, just 2 times 2, either 2 to the 2nd or 4. How many p's? -9 and -3. P to the -12th. And at this point, if we stop, it's typically going to be counted wrong because normally we do not want to end with negative exponents unless we're working with scientific notation, and we're not. So this is an elevator ride again. But the 4 is not on the elevator. The 4 is raised to a positive exponent. So 4 stays, p goes, drops its negative, 4 on p to the 12th. All right, if you've been paying attention, you're going to catch this common mistake right away. Here I have 2m to the 7th to the 5th. Here is the common mistake, 2m to the 35th. This 5 affects that 7, but this 5 also affects the sneaky hidden 1. 5 groups of 7, 35, but 5 groups of 1, 5. So 2 to the 5th, m to the 35th. Or can you do 2 to the 5th in your head quickly? That's 2, 4, 8, 16, 32, m to the 35th. So I hope that's helpful. Again, this is a skill that after you've practiced for a while, you should get very quick, very accurate with, but it may very well be, you got a test coming up or semester exam. It may be something you want to come back and review this video, but this is a very important skill as you move into geometry and algebra 2 in the future. So hope that was helpful. Visit back often, and good luck.